Cletus, he said, maybe stop playing with your do-rag.
It did.
You do.
The accent came out a little thicker than normal. Okay, so we are... Okay, so we are still talking about exponential functions. So again, a and b are our constants. A can't be 0, b has to be positive, and it has to be bigger than 1. Or it can't be 1. So a is our what again? Then b was our what?
Constant ratio.
So the specifics we're going to look at today are growth and decay functions. Okay, so exponential functions are usually used to model this type of equations. Okay, and we're going to talk about some specifics today. So for a growth or decay function, okay, we have to first figure out if it's growth or if it's decay. So in order to do that, we have to look at our b in the equation first. If it gives us our equation and our b is greater than 1, it is a growth function. Okay. And if it's a growth function, your graph will grow away from your x-axis as it goes from left to right. So to the side over here, we're actually going to sketch it. You're going to put your little x-axis, and then you're going to put your graph on there. So it's going to start really close to the axis, and then it's going to grow up. Now, what's something you would want to grow like that?
The money.
Your money. So we're actually going to talk tomorrow about interest formulas and how compound interest works and the stuff that actually is the formulas for those things. So, now, what happens, though, if your b is less than 1? So if your b is less than 1, okay, that is where you have a decay function. And if you have a decay function, your graph will decay towards the x-axis. And so we're going to draw our x-axis again. And then our graph this time is going to start high, but then it's going to get closer and closer to our x-axis. What's something you can think of that's value decays like that? Cars. The second you drive a brand new car off the lot, what happens to the value? It starts depreciating. That relationship can be modeled by a decay function. Okay. Now, so B is our constant ratio. All the examples we've done so far, we already know what our B is. It tells us what our B is by either using a table or whatever. But in growth or decay function, it's going to tell us the rate at which our graph is changing. We have to use that rate to find B. So what we'll do is you'll have B is equal to 1 plus or minus R, where R is your rate. Okay? You will also look right there. That rate is typically a percent. It is typically a percent. So another thing about this, okay, is I want us to actually use which formula we're going to use for these. So for growth, our B, okay, to find B, do you think I would need to add or subtract to find my growth B? Add. We're going to say 1 plus our rate, and that will tell us our B for growth. So the way we can kind of think about that is we're going to be looking at it if we're looking at the function f of x is equal to our A times 1 plus our rate to whatever x is. Okay, that's kind of what we're doing. Then for decay, okay, so for decay, we're going to be looking for our b, where it's 1 minus our rate. And so what a new function would look like for this is you still have your a, and it'll be times 1 minus r, all to the x power. And that's what I have up on the board up there, okay? That's a way for us to think about the different parts of this function and how it works and everything. So we're going to do 2 examples together today, because I think that's all we got time for, okay? And we're really going to go through it and kind of figure out all the things we need to do, okay? The way we're going to go through this is kind of the approach you need to take to every single one of these problems. We're kind of going to step through it. And the way we're going through it is the same way you should go through it for your problems. So for number 1, it says the population of a large city was about 4.6 million in the year 2010. And it grew at a rate of 1.3% over the next 4 years. So first, what is our A? What's our starting initial value?
4.6.
4.6 million. That right there. That is our, that is our A. Now, out of curiosity, if I wanted to write that as an actual number, how would I write it?
4, it would be 4, 6, 0, 0, 0, 0.
And how would I read that number?
4.6. I mean, 4,600,000.
$4,600,000. Yep. Now, it's not money, it's people. I said dollars. I know, that was my bad. I was hoping y'all didn't. I stopped saying it, but I was hoping y'all just didn't hear it, but I wasn't that lucky. All right, now, what is the rate at which it grew?
1.3%.
So that right there is our rate. Now, when we write rate, we cannot write it as a percent. Okay? So when we change something from decimal to percent, how do we do that?
We like divide by 100.
You can divide it by 100, or you can just move the decimal place 2 times. Either way works. So when I convert 1.3% to a decimal, what am I going to put? 0.13. 0.013.
Oh, there it goes.
Okay, we have to have that 0.013. The reason for that is if you're going to convert between the two, actually, where's be somewhere I can write with lots of space? Okay. If you're converting from a percentage, okay, so if we have 20%, the way you can convert that is if you have a point here, okay, you move that point over 1, 2. So 20% is the same thing as saying 0.2. But if I have 2%, okay, that decimal still starts here. So I'm going to move it over 1, 2. So that is the same as, y'all see how there's nothing in that spot? So we had to add in a 0, so it'd be 0.02. So that's what we're doing when we convert just using decimal places. You can also just take whatever your percent is and divide it by 100, and it will tell you it is 0.2. Or if you do it this way, it will tell you that it is 0.02. Okay? Either way works. So we have everything we need from the question now. It's actually time for us to start calculating some things. So in part A, it asks us to find our growth factor. That right there means we're finding our B. So since we're looking at growth, do I need to add or subtract? So we're going to do 1 plus our rate, which is 0.013. What is 1 plus 0.013? 1.013. That is our B. That is our B. And so the next one actually wants us to write out our equation, okay? So I'm going to show us 2 ways we can write this equation, okay? You can find your B first, and then just write your equation as, what's your A again?
4.6 million.
Okay, so whenever we're dealing with millions places, if it gives you your number and as like 4.6, you can use 4.6. But if it gives you your number as writing the whole number out, you have to leave the whole number in there, okay? So 4.6 times, we can either just go ahead and put b in here, so 1.013 to the x power, or you could have just set it up and kept it as 4.6 times 1 plus 0.013 to the x power. Either of those ways of writing the function will give you the right thing, okay? Either thing works. I do not care which one you do, okay? But this question doesn't just ask us to write the... This question doesn't just ask us to write the function. What else does this ask us to do?
Exponential function, that model population, this is over a 4-year period.
Over a 4-year period. What do you think that means we need to do?
Go over 4 times.
I need to plug in what number?
4.
So we're going to find f of 4. And so we're going to say 4.6 times 1.013 to the 4th power. And I need you to type that in your calculator for me. If you don't have a calculator, go get you one. The yellow packet? I can get you that. I'll grab it for you real quick. Let me see if I have any more up here. Jairi, wake up. It's not yellow, is that okay?
Did you go upstairs?
You said you're sick, right?
Did you go upstairs? Did you go
All right, y'all. So, have any of y'all been able to type that into our calculator yet? What did we get?
1.31.
What was that?
1.31.
I got 4.8439049.
We should get 4.8. Okay, let me look at your calculator and see what happened. Did you put the 1.013 in there, or did you just put 0.13? Okay, so you have to add in. All right, now, so what's our answer in terms of 4.8 million what? Or 4.8 what?
Million growth over the years.
Million. Okay, y'all, please be quiet. Just because I stand up and I ask a question or whatever, that doesn't mean y'all start talking. Okay, if we're working, we're working. The classes that have got this today are the classes that have paid attention. The classes that have talked don't get it. Not because it's not hard, not because it's hard, but just because we're not paying attention. So let's do what we're supposed to do, please. Okay. So that's the population after 4 years. Now C says the population continues to grow at the same rate. What will the population be in 2040? How many years forward in that question is that? 30, because it goes from 2010 to 2040. And how many years is that? 30. So what are we going to do now?
8 times 30.
No, not 4 times 8 times 30. We have to take that equation, but instead of plugging in 4, what do I need to plug in now?
30.
And so we will do 4.6 times 1.013 and raise it to the power of what? 30.
But why couldn't you just do 4.8?
So what is happening in this problem? Okay, and how this problem is different than a lot of other percent problems, right? Because if I wanted to figure out what's 20% of 35 for like a shirt, right? I just multiply that. The reason this is different is because what's happening is it's not just calculating the percent of the total population. It's calculating the percent of the population this year. Then it's adding that to the number for the next year and doing that with the number for the next year. So it's taking the population, right? And so every year, what's happening to our number of the people in the population. It's going up, right? And so it's calculating that new population from the next year using that bigger number. Okay, so that's why it gets so big so fast, is because as it's doing it exponentially, it's doing something a whole lot different than just multiplying the two things together. Does that make sense? And so it's using all of the years that's happening to calculate those numbers. And like tomorrow, we're actually going to do it with like interest formulas and stuff like that and see what happens with money when we do stuff like this. Okay, so what is my answer to this question?
6.8. It's like 6.05.
We can do 6.8. So we can do 6.8 million.
So with 6.77, you're wrong.
No. Okay, and if I wanted to write that as like an actual number, how would I write that as an actual number?
6,800, comma 00.
And how do I read that? 6,800,000. Yep. All right. So that is how we do a population problem. Okay. This example is a population problem. Anytime we have a population problem, that's how we do it. Now we're going to look at a car problem. So this one. It tells us that a car was purchased for $24,000. Okay? What is that? What is that right there?
The 8.
That is our A.
Yeah, that's an 8, yeah.
Yeah, that's not a new car. More than likely.
Yeah, probably like.
All right, now, and it also says the function that it uses to model it. So this function next to it.
Y is 24 times 8, 0.8.
To the x power, okay, can be used to model the value of the car in thousands of dollars after X years after it was purchased. So it asks, does this function represent growth or decay?
Decay.
Why is it decay?
It's less than 1.
Yeah, because less than 1.
It is decay because B is less than 1. Because we can see that right there, that 0.8 is less than 1. And then it asks us what the rate is. What was the formula for finding my B for a decay function?
It was B equals
1 plus 1 minus R.
Yeah. And in that function, what does it tell me?
That you have to.
Does it tell me my B or my R?
Tell your
B.
I mean, wait, what?
The equation. What I've got highlighted in blue.
Oh, it tells your.
B, right? So we're going to say 0.8 is equal to 1 minus R. So how would I use that to find R? What is R?
That's your rate.
It is my rate. So what is it in this problem?
Is it 24 times 0.8?
0.2 or 20 and how would I write 0.2 as a percent?
2%.
20%.
Oh,
20%. Okay, so the car, because it asks us what does it mean. So we're going to say the car value increase or decreases? So the car value decreases at a rate of 20%. So then it asks us to figure out how much the car will be worth 7 years after it was purchased. Okay? So we have to find our function. We have our function, don't we? So I'll do f of 7 is equal to 24 times 0.8 to the what power? But I'm evaluating it, so put that in your calculator.
I got 5.033168.
We'll do 5.03.
Yeah, that's what
All right. But we're talking about money in thousands of dollars. So how would I rewrite that as money in thousands?
Oh, dang. $5,033.
Yeah, so we can do 5,000
And 3 cents.
No, not 3 cents.
and $30. Okay? So we add on, we take that, so however many decimal places are in front of that 3, that's how many zeros we would put in the front of the 3. And it is $5,030. Okay? And that is how we do these. Okay, so what we are going to do is I want you to flip over your paper and I want you to do number 3 for me.
Oh, we're not doing the thing on the
We don't have time. I'm going to get us to start class tomorrow with it.
What thing on the computer? I'll just hear it. I wouldn't see.
Everybody else said an exit ticket on the computer, but unfortunately, we don't have quite enough time. Because we had to go back and do the, because you know how y'all didn't have y'all's homework sheet yesterday? Or today? We had to go back.
Oh,
We're good though.
so
We're actually a day ahead.
Where'd it go?
our test next week,
I
right?
lost it.
We'll make sure I was reading that right.
I think we'll actually get 2 days of review, hopefully. Because we're a day ahead right now.
Okay, so
So instead of doing growth and decay again on Monday, we're going to go ahead and do 6.5. Because tomorrow we'll finish up growth and decay.
you get like a baseball fatigue.
No, yeah, I'm not feeling it.
It's going okay. Have you done number 3?
Not for you. Not for you.
Oh, we're supposed to be doing?
Yeah, do number 3. I want you to actively do number 3. Ashton, where's your stuff at? Did you lose it? You just didn't bring it today?
Sure, buddy. Sure, buddy.
You don't have one? What do you mean you don't have one? And then you've been in here and you've not asked for one?
Well, I went up there and I tried to find it, but
Up there, it's hard to...
last time you said if we didn't get one, like, we couldn't get one.
No, that was if you lost it.
Uh-oh.
Because I only make copies for the right number of people. Because, like, I have, like, 3 left.
Thank you.
I only don't want you to do that if you have lost it. But, yeah. If you've ever just not got a paper, ask for it. And the only reason I don't put them up there is because it's been hard to do that when I'm doing the whole set of notes. Because then they'll come in, people will come in and miss a day, and then they'll think they need to get a whole new set of notes. They don't need a whole new set of notes. Freedom, do number 3.
Up on the board?
No.
the other number 3.
Do number 3 on your paper.
Man, that was so funny, man. Threw a bottle at me. You're like, hey, Kevin, we're gonna grab it. Let the bottle.
Yeah.
It was a wonderful moment, though. It was a wonderful moment.
No, it's not.
Yeah, in the moment, in the moment. No, it wasn't. You had to, like, see how it was spinning. It was spinning, like, on the side.
Actually, you know what? I owe you 2 again for BBK. 2 more, just for me thinking about it.
One of them said that.
2 more, just for me sitting here.
Dude, Caleb said that.
Yeah, that's ridiculous.
Caleb literally said, yeah. Caleb said, BBK. And nothing was great. I said, you gotta do the other. That's what I said.
That's what Dizzo did yesterday at practice. It was so funny. And Coach Armstrong was talking to us. He was trying to have a serious talk. And we all sat on the floor in front of him. They like clapping off the grass. Then I said, I started dying.
This dog-
Oh my God, I started
Mhm.
dying.
Can I get a dental tissue real
Until
quick?
the sound like clapping off. Man, that joke was hilarious. He's like, y'all be serious for one? That joke's so funny too.
All right. Let's go ahead and go over this.
I'm almost done.
Almost done? Okay, I'll give y'all till 1:40 to finish this question.
Shut up. I'm done, Miss Dawson.
Perfect. I'll give you a few more minutes. Not you, but everyone.
He's a lot. He did not do anything.
I got 0. I got 0
You been
point.
knowing him, he done his work.
I got 0 point. I got 0 point. 0.075.
I have to present it.
What you gotta present?
I have to remember
I
something
did my
in like
hand.
15 minutes.
I've been in here I've been taking 2 math classes for the past week.
That's fine.
Every review day we have to do it.
And then for my other answer, I got 7.1, 7, 8, 1.46, and 3, 1.
It's a little better than 15.
What you talking about? Amen. What you gonna do?
You have 20, oh, y'all have 25 minutes to memorize?
What are you
You
gonna
have to
do?
have something 2 minutes long about the chapter.
I mean, that's a good way to,
It doesn't remember. I can't remember.
yeah. I would just make a song of all the important dates.
Before you get me. I hope you know that.
I wish you would.
Because that was the only part, like, I could remember who did what. I could remember the people. I could remember all of that for history. But I couldn't remember the dates.
That was funny when we was like,
Especially for her, because like on the
playing
notes,
with
she
your
goes
guru right
like, she does like a 15-page thing in 5 minutes. Like she talks so fast.
Yeah.
Yeah, she closed down all the notes.
So you can't go back to school with you to like.
Studies. It's bad.
All right. So for this question, okay, what is our A in this question?
50,000.
That is our A. Okay. What was our rate?
0.075.
Yep. So it is 0.075. All right, so it says write the exponential model to represent the sculpture in thousands of dollars. So the value of the sculpture. So f of x
Yeah, F of X equals 50,000 equals 50,000 again.
He's looking on my paper.
No, I'm not. I did my head.
I just saw you look down at this paper. I'm watching you.
Now what do I need to do?
My paper's right here.
Times 1
Yeah,
plus 0.075 to the x power.
1 plus 0.075
That's valid.
to the what power?
The x
to
power.
F power, yeah.
X power. I would have also accepted that equation as being written as f of x is equal to 50,000 times 1.075
That's what I did.
to the x.
I did.
Kenan, are you lying?
I was literally thinking
On your
I was thinking of it that way.
Do I need to call the fire? Do I need to call the fire department?
Like your pants on
Or your-
fire.
No, I literally did that in my head. I did that.
All right, now, so after we find that function, okay, we have to find the value of the sculpture in 5 years. So what do I need to do that?
You have to put the
X
5 instead of X.
I need to plug in 5. So once we plug in 5, we will do 50,000
Like 1,000.
times
1 plus 0.75.
0.75.
to the 5th power, which is equal to what?
which is equal to 71,781.46631.
Okay, so 71,781
Yeah.
point. Now, this is money. How many decimal places does money go to? 2. So we need to put this at what?
4.7. I mean,
No,
4.7.
0.47. Yeah.
0.47. Okay,
All in the head.
so there we go. That's the value of the sculpture.
Can you also round that up?
No, you can't.
Can you? Because it's money. So we gotta leave it with 2 decimal places with money.
You didn't do it.